We're going to move on to graphing some slightly more difficult rational functions. So let's look at number 1. Our first step here is to factor this out as much as we can. So the numerator is already factored out, x plus 1. But our denominator, x squared minus 4, we can factor out using difference of squares. So this is x minus 2, x plus 2. Once we have this, now we're going to follow all the same steps. So our domain, we know, is the denominator cannot be equal to 0. So our denominator is the x minus 2, x plus 2 does not equal 0. We're going to split it up into two separate equations. So x minus 2 doesn't equal 0, x plus 2 doesn't equal 0. Just gives us two different answers. We have x does not equal positive 2, and x does not equal negative 2. So that's our domain. To find our vertical asymptote, how are we going to do that? It's the same as our domain, so we're going to have two separate lines here. X is equal to positive 2, x is equal to negative 2. So I'm going to go ahead and graph these on my graph. So 1 and 2. Here is positive 2. I'm going to draw a dotted line at positive 2. And also one at negative 2. So those are my vertical asymptotes. Now to find my horizontal asymptote, I'm going to try to divide long division. So x plus 1 divided by, again, our numerator always goes inside the division house. We have x squared, there should be a placeholder 0 here, and then minus 4. So when we try to divide this, what we're going to do is first term divided by first term, x divided by x squared. Can you divide x by x squared? No, you can't. The degree on top is smaller than the degree on the bottom. So this is already in proper form. If it's in proper form, then it stays as this fraction, and we know the fraction goes to 0, so our horizontal asymptote is y equals 0. And again, we're going to graph that, so y equals 0 is going to be right on the axis. I'm going to draw a dotted line right on the axis. So now I have my asymptotes, vertical asymptote and the horizontal asymptote. To find my x-intercept, this is when y is equal to 0. So we're going to use what part of our fraction? Just the numerator. So we're going to set the numerator equal to 0. Our numerator is x plus 1 equals 0. To solve for x minus 1 minus 1, x is equal to negative 1. So again, it's a point. So negative 1 and our y is equal to 0. And we're going to, again, plot this on our graph. So negative 1 comma 0 is our x-intercept. It should be on the x-axis. This is negative 1 comma 0. That's my x-intercept. For my y-intercept, x is equal to 0 now, so again, I know it's going to be a point. It's going to be 0 comma something. To figure out what it is, I'm going to plug it into my equation. So I have 0 plus 1, and then I have 0 squared minus 4. Gives me 1 over negative 4, which is negative 1/4. And negative 1/4 is going to be a fraction somewhere between 0 and negative 1. So I'm just going to draw it right here. And now all I have to do left is graph the rest of my graph. So this is when sign analysis comes into play. So I'm going to draw it right underneath the graph so I can see them line up. The important points on my x-axis. I know I'm going to have to figure out what's happening at negative 2 and at 2, because those are my vertical asymptotes. There's also a point at negative 1, because that's my x-intercept. So these are the important sections that I need to figure out what's happening. So let's start off with the left side of negative 2. So let's pick a number over here that's on the left side of negative 2. So let's say we're going to use negative 3. So we do f of negative 3. I'm going to plug it into my function. So x plus 1 over x minus 2, x plus 2. I'm going to use the factored form. So this is negative 3 plus 1 over negative 3 minus 2, negative 3 plus 2. And I'm trying to figure out, is it positive or negative? Negative 3 plus 1 is negative. Negative 3 minus 2 is also negative. Negative 3 plus 2 is negative. So this is negative divided by a negative times a negative. We know negative times a negative is actually a positive. So this is a negative divided by a positive, which leaves us with a negative. So I know that on this side of negative 2, it's going to be negative, which means it's going to be below the x-axis. So I actually know what this is going to look like already, because just like our rational parent function, it's got to approach the asymptotes. So this is what this section is going to look like. Now I want to know what's happening between -2 and -1. So what's the number between -2 and -1? Let's use -1.5. So again, we're just going to plug in -1.5 plus 1, -1.5 minus 2, and -1.5 plus 2. And this numerator is going to be negative. This is going to be negative. -1.5 plus 2 is going to be positive. So negative divided by negative times the positive is negative. Negative divided by negative is actually positive. So this section right here is going to be positive, which is above the x-axis. So I know from this point, it's going to now go up towards the asymptote between -2 and -1. Between -1 and 2, we actually already have a point here because we could pick f of 0. We've already found f of 0. It's our y-intercept. It gave us -4. So we know that this section right here is -4, which is a negative number. So everything over here is going to be negative. So we're going to connect our points, and this is going to go down. And we have one last section. Let's pick a number bigger than 2. So let's say 3. When we plug in 3, it's going to be 3 plus 1, 3 minus 2 times 3 plus 2. So this is going to be positive, positive, and positive. So positive divided by positive is still going to be positive. So this section right here is now going to be above my x-axis. So I know it's going to open towards the asymptotes again, on top of the asymptote. So this is my final graph for number 1. Now let's do one more example problem. Let's look at number 2. So again, step number 1, we want to factor. So what two things multiply to give me -6 and add to give me 1? So I know 1 and 6, 2 and 3. So it should be 2 and 3. Because it's a positive one, I'm going to make the 2 negative. Right, so because there's no number in front of the x squared, I don't need the box. So this is just x minus 2, x plus 3. Let's do the same thing for the denominator. What two things multiply to give me -2, add to give me 1. In this case, it's going to be a 2 and 1, and I want the 1 to be negative. So I have x plus 2, x minus 1. So this is factored form. Okay, now let's look at our domain. Again, denominator does not equal 0. So our denominator is x plus 2, x minus 1 does not equal 0. We're going to get two answers here when we solve. We get x does not equal -2 and x does not equal +1. Vertical asymptote same as our domain. So x equals -2, x equals 1. I'm going to go ahead and draw this on my graph. So -2. And then 1 are my vertical asymptotes. For my horizontal asymptote, I'm now going to divide. So x squared plus x minus 6 divide by x squared plus x minus 2. So first term divided by first term, x squared divided by x squared. A number divided by itself is just 1. So 1 goes on top. Multiply out. Change the signs. This gives me a remainder of -4 because I can't divide -4 by x squared. But a remainder doesn't matter because the remainder goes to 0. So my horizontal asymptote here is just this number, which is y is equal to 1. So I'm going to draw a horizontal asymptote at 1. And here are my asymptotes. Now for my x-intercept, numerator equals 0. My numerator here is x minus 2, x plus 3. So I'm actually going to have two different answers here. If I have x minus 2 equals 0, plus 2, I get x is equal to 2. If I have x plus 3 equals 0, minus 3, I get x is equal to -3. So I have two different x-intercepts, 2, 0, and -3, 0. And I'm going to graph both of those on my graph. So 2 is right here, -3 is right here. And then my y-intercept, now my x is 0, I'm going to plug it in. So y equals 0 plus 0 minus 6. 0 squared plus 0 minus 2. So I end up with -6 divided by -2, which is just a +3. So my y-intercept is 0, 3. Now I'm going to plot that one as well. Y-intercept should be on the y-axis, so this one's up here. Okay, now that I'm done with all these, all I have left to do is my sign analysis. So here's -2, here's 1, and I know that I have a point at -3 and a point at 2. Okay, so this is actually a pretty simple one, because using our points we can actually figure out what most of our graph is going to look like here. So if we look at this point right here, we know that we want it to go through this point. So if we want it to open up towards the asymptote, this one has to go towards this asymptote. And this one is going to go towards this asymptote because it looks like a rational function. Right? So we already know that this section is going to look like this. Same thing over here. Right? So this one we want it to open up towards the asymptote. So we already know that these two sections are going to look like that. So what this means is on this side of the -3, this is positive, this is negative, this was negative, and this is positive. So if you had done sign analysis, it would have given you the same results. Okay, so for the middle part, let's pick a number between -2 and 1. Let's say we pick 0. We know 0, 3 is our point. So this is actually going to be up here as positive because we already have a point up here. We know it's going to be above the x-axis. So for this section, we wanted to also approach the asymptotes on both sides. Because it's positive, we want it to be going up on this side and also up on this side, because this whole section is positive. It never crosses the x-axis, so it should not be going down because there isn't an x-intercept right here. So this is my final graph for number 2.